right now. We're going to take our hood off. There we go. All right. Okay. Okay. All right. So yesterday we were talking about roots, and we already kind of knew about square roots. Square root of 4 is 2. Square root of 36 is 6. We knew about those. But we talked about cube roots and fourth roots and fifth roots. So something like the fourth root of 81 would be 3, because 3 times 3 times 3 times 3 equals 81. Okay? So we talked about those roots that we had not talked about before. Then we began really quickly talking about writing radical expressions with rational exponents, or fractional exponents. So if we have a root, and there's a little b out here, and there's an exponent of a on the inside, then we would write this as x to the a over b. So the exponent on the inside goes on the top, the root goes on the bottom, because roots go on the bottom of a tree. Right? So let's look at number 7 right here. All right. So we've got the fifth root of x squared y to the third. So whenever we have two things that are multiplied here, both under the root, we've got to write both of them as the fractional exponents. So we would write x to the, there we go, x to the 2 fifths. The exponent goes on top, the root goes on the bottom, and y to the 3 fifths. If they were both x's, we would. But we've got an x and a y, so we can't put them together, so we'll just leave it like that. We're going to get to somewhere we've got to do that. So, okay? So for 9, Adam, what would we do? What would we have? That's it. You would just have to leave this one like this. There's nothing else you can really do for that. Very good. X to the 1 over 3. Where'd you get that 1 from, Adam? Oh, we should have. I was working across. It is just going to be 1, just for the sake of the notes, I'm going to write 3 over 3, but it's going to reduce. We'll fix it here in a second. And then z to the 4 over 3. Now, for number 9, because I skipped 8 for some reason, whenever we do this, the top, this right here did not have an exponent, so it had a 1. We have 1 over 3, 3 over 3, and 4 over 3. But 3 over 3 is 1, so we could write it like this. X to the 1/3, y, z to the 4/3. Yes. Yes, and please do if it'll reduce. All right, number 8. Gabe, number 8. How are we going to write that one? What's the root? Because there's nothing out there. This had a 5. This one had a 3. There's nothing out here. So what type of root? It's not a 1. It is a 2, because that is a square root. Now, a coefficient, as far as a coefficient, like you would have a 1 times that out here, but that's not what we're talking about for this. The root is a 2. So if you have a root without a number out front, then it is a square root, so there is a little invisible 2 right there. So when we write this as fractional exponents, what will we get, Gabe? Very good. X to the 3 over 2. And y? 8 over 2. And 3 over 2 will not reduce, so we would leave it alone. But y would be y to the 4th. Very good. Yes, you would simplify and make it 3 halves. Yes. Monica, what would we get for number 10? Good? Very good. Will anything simplify there? It will not. We'll leave it alone. Okay? Julie, what about number 11? Okay? X to the 5th. I'm going to write this step. You get 5th because you do 25 over 5, right? And then that will reduce to x to the 5th. You don't have to write that step, but because I'm giving notes and I want everybody to see where it came from, I'm writing that down. I didn't know one way or the other, but I had confidence in it. I knew. Okay. All right. Number 12. Evan, what would we do for number 12? Okay, very good. The x, will it reduce? It will reduce. It won't reduce to a whole number, but we could reduce it. So let's go ahead and reduce. What would we get when we reduce? We'll get 3 over 2. Okay? All right, questions? Okay. Let's look at the next one. So the main thing you're going to have to do as far as this goes on the quiz tomorrow is you're going to have to be able to write something that's written as a radical. You'll have to write it with fractional exponents. And then you'll also have to be able to take something that has fractional exponents and write it back as a radical. Those are the 2 main things. We're going to do a little bit more with it here, and it will be on your test. But as far as the quiz tomorrow, like through number 18, those are the main things that I'm asking you to do tomorrow on the quiz. Now, the quiz will also have stuff like we did on the warm-up. It will have stuff like you did for homework that doesn't have fractional exponents on it, but it will have a couple of these questions. So, for 13, if I've got x to the 2 over 5 and I want to write that back as a radical, then I would have a root. It would be a 5th root because the root is on the bottom of the tree, so it goes here. That means I'd have x squared. Like this. I should also tell you, if you see this, sometimes you'll see it written like this, the 5th root of x squared. Sometimes you'll see the square on the inside. Sometimes they'll put the square on the outside and square the whole thing. Either one is the same. So if you see either one of those could be correct. So if you get this is your answer, but it's not there as an answer choice, it might be this one instead. Okay, so those are equivalent. Cole, what would we get for number 14? Okay. Uh-huh. Like out here? Nope. Because this is your root, right? The bottom of the fraction is the root, so we put that right out here. Except for, do I need to write it whenever it's a 2? I do not. And then the 1, that's your exponent that goes right here. But in this particular case, you don't need to put the 2 on the outside because the square root we don't have to write it. And you also don't need the 1 on the inside because we don't have to write it whenever we have something to the first power. So this one would just be the square root of 8. You can, but tomorrow will be multiple choice and that it will not look like that. It's going to be multiple choice. So you will not see this as an answer choice. Yes, it is. Yesterday I said I wasn't sure, but I've decided to do it on the computer. No, I do not have a bathroom tent. If we get put on lockdown and you got to go, then you're just out of luck. All right. All right. Okay. All right. Zena, what would we get for 15? Okay. We call it the fourth root. Very good. Okay. All right. That is what you're thinking of dividing, and this is what you're dividing here. Yeah. But these are roots. They're not dividends. You're not dividing. You're thinking of this symbol instead of this symbol. Like this would be like if you're doing 125 divided by 5, that's division. This is a square root here. Okay? All right. Dakota, what do we get for 16? Very good. All right, everything's going good. These are pretty easy till we hit 17. Okay, I like what Connor just said here. He said we should do 15, right? So, because if we want to put these underneath the same root, they've got to have the same denominator, right? I guess we could write the fifth root of x squared and the third root of y to the fourth, but I would kind of like for them to be all under the same root. So we need common denominators. So to make this 15, I'd have to multiply by 3 on the top and bottom here, and I'd have to multiply by. Right, so I have x to the 6 over 15 and y to the 20 over 15. And then I could write that as the 15th root of x to the 6th, y to the 20th. Now, if you write them as separate roots, you could do the fifth root of x squared and the third root of y to the fourth. That is correct. So, what you'll have to do is like tomorrow, you would have to look at your answer choices. It is possible that this might be the answer choice. But it's also possible that the answer choice might look like this, where we put it all under one root, so you'll have to know that they would not both be there as answer choices because they're both correct. But I'd like for you to try to put it all under one root for this. Mm-hmm. Okay, what would we do? Yes, 12. Good. So to get 12 for that first fraction, what have we got to multiply by? 4. So we're multiplying by 4 in top and bottom. What about the second one? 3 in top and bottom. And the last one? 6. Very good. So that would give you 12 as the denominator for all of these. So you got 4 over 12, b to the 3 over 12, and c to the 6 over 12. And so when we write that, Zena, what will it look like when we write it as a root? Yep. Okay, very good. Okay. All right, questions? Okay, this is the sort of stuff, as far as this stuff goes, that you're going to have on your quiz tomorrow. Okay, you will not have long problems on your quiz tomorrow because we're going to practice them some today, but we have not practiced them enough for me to put the really difficult ones on the quiz tomorrow. So this is what you'll be asked to do tomorrow. You'll be asked to rewrite them as a fractional exponent or as a radical. But we are also going to practice doing some problems with these. let's look at, we've got some with some numbers, and then we've got some other more difficult ones. So, 4x to the 1 over n. Okay, this is something that, and it doesn't actually have to be 1 over n, it could be a over n. Change the expression to a radical and evaluate by asking yourself what times itself n times will give me this x. So whenever you have something like 9 to the 1/2, because you will not have a calculator tomorrow, right? So if you see something like 9 to the 1/2, or I don't think, this might be on there. I can't remember if this is on there. I know the next page stuff is not on there. If it's not, even on the test, you will not have a calculator for this. So you can't type 9 to the 1/2 into the calculator. So what you got to do is you got to rewrite it as a root. Okay? So 9 to the 1/2 would be the square root of 9 to the first power, which is just the square root of 9. And Gabe, what is the square root of 9? It is 3. So whereas 9 to the 1/2 sounds really bad, square root of 9 should be something that everybody knows really well. Okay? So, Abby, for number 20, if we rewrite that one as a root, what will we have when we rewrite it? Okay? So, the cube root of 125. And what is the cube root of 125? What do you think, Evan? It's 5. Because 5 times 5 times 5 would give you 125. Right, this would be 25 times 5. If you have 5 quarters, you got $1.25. 125 there. So it would be 5. So anything that I give you because you don't have a calculator, it's going to be something you're going to get a whole number for. I'm not going to give you one square. It's a big decimal where you do need the calculator for. Hello? Yes. I sure do. Oh, okay. Yep. I can send him. Thanks. Evan, they need you in guidance for a minute. Okay? It will not be 9. Because what type of root, Julie, are you going to get? You'll have 81 to the first power. What type of root do you have? A fourth root. The square root of 81 is 9. But the fourth root, we would have to do 9 times 9 times 9 times 9, which wouldn't give us, that would not give us 81, right? Okay? All right, so 3 or 4, let's try 3. No, it needs to be a little number. We're asking ourselves, what number times itself 4 times would give us 81? Okay? So 3 times 3 would be 9, and this 3 times 3 would be 9, and then 9 times 9 would give you 81, so 3 is the answer. So there's a little bit of guess and check, especially with these here, where you're kind of guessing. They're usually pretty small numbers, especially if they're like 4th roots or 5th roots or bigger numbers, because whenever you do this, you're going to get, it's got to be pretty small numbers to multiply something 4 or 5 times. No. but let's do it. All right, so it's going to be the cube root of 8 squared. Now, let me show you something, Julie, because you were correct about the cube root of 8 being 2, right? So you could change this to the cube root of 64 and figure out what it was, or you could write it like this. You could write it as the cube root of 8 times the cube root of 8. Right? What did you just tell me the cube root of 8 was? You said 2. So 2 times 2 would give you 4, and that would be the answer. Or you can do 64 and say 4 times 4 times 4, and that's 64, so you get 4 there as well. So if you have something raised to a power here, and you know the cube root of it, you could just multiply that twice, right? The cube, or you could think of it like this: the cube root of 8. I told you it could be written like this: cube root of 8 squared, where we have that square on the outside. So you could do the cube root of 8 first, which is 2, and then you could square it, which will give you the 4. I can't remember if this is on the quiz tomorrow. Possibly, but the next page is definitely not. I can't remember. I know the first stuff is. This I can't remember if I put ones that were just numbers or not. Alright, so, Hayden, what type of root have we got for 23 if we rewrite this as a root? What little number's on the outside of the root? A 2. And then we'll have 4 to what power on the inside? Third. And it really might be better if we do write it like this. If we write that square root, I don't have to put the 2 because since it is a square root, it's automatically a square root if you don't put it. So square root of 4, and I could put this to the third on the outside. What is the square root of 4, Hayden? 2. So 2 to the third would be 2 times 2 times 2. It would give us 8 there. So I think that is easier to do than trying to find 4 to the third and then take the square root of it. It's not that bad. 4 to the third is 64. The square root of that is 8, but I usually do it that way instead. All right. Okay. Dakota, what about number 24? Fifth root is what we call it. Fifth root. Okay, and it is going to be 5. Well, let's see. Did you say 5? Okay, yep. It's just by itself, yes. So, what number times itself 5 times is going to give us 243? Okay, I think 3 is probably going to be it. Do you guys know this trick about knowing if something's divisible by 3? When I have 243, if I do 2 plus 4 plus 3, it's going to give me 6, 7, 8, 9. If you add all the digits up and that is divisible by 3, then the number is divisible by 3. It only works for 3. Yes, it does not work for other numbers. But it will work for 3. So, like, for example, here for 81, 8 plus 1 equals 9. 9 is divisible by 3, so that number is divisible by 3. So, for example, 64, like if I don't know the cube root of 64, 6 plus 4 is 10. 10 is not divisible by 3, so I know 3 won't be the answer for that one. It helps you rule them. It doesn't necessarily mean 3 is the answer, but it does help you rule some of them out there. So this is 3. If you multiply 3 5 times, you would have 9 times 9 times 3, so that'd be 81 times 3. So you get 3. Okay. Questions? All right. So we're about to enter a time. Yes, the danger zone is about right. We're about to enter the danger zone, and the danger zone is the time when I ask you to do something with fractions without a calculator. Because we've worked on fractions some, mostly first semester, but fractions are the downfall of children in math. But fractions don't have to be that bad. Okay, they are harder than just having regular numbers, of course. If I've just got 2 times 3, that's much easier than 2/3 times 4/3. But fractions are doable. They teach them to you in the 5th and 6th grade because you can learn them in the 5th and 6th grade. They're not some sort of super high level math that you can't understand. So, let's review because we're going to have to be able to do this. So, to add and subtract fractions, we need to get like denominators. add the numerators. You do want to keep the fraction bar, but that is not what I want here. Think about it. If I'm adding 1/2 plus 1/2, I've already got like denominators. I add the numerator. 1 plus 1 is 2. What do I do in the bottom? Keep the denominator. You keep it the same. You do not add the denominator. So keep the denominator. And remind me, what's the denominator? That's the bottom of the fraction. What's the numerator? Top. Denominator starts to almost looks like demon on the bottom. They just decided they wanted that fancy name to refer to the denominator of a fraction. You just sound a little more sophisticated. Whatever. Right. Just makes us sound fancier. Sometimes you just want to sound fancier. Alright, to multiply fractions, what do we do? Okay, multiply the numerators together. And multiply the denominators. Together. Okay, easy as pie. Flip. Alright, so dividing fractions, easy as pie, flip the second, multiply. Or whatever other rhyme you like to help you remember. Okay, so we are going to have to add, subtract, multiply, and divide some fractions here in this next part. So that's why we're going over this right here. Alright, how to simplify radical expressions. Okay. So if we have an example here, the cube root of 8x squared y to the 5th times the square root of 16x to the 3rd. Okay. The first thing I want you to do is I want you to take the root of the coefficients if possible. Most of the time it's going to be possible because I want you to get whole numbers. So what is the cube root of 8? Cube root of 8. What number times itself 3 times 2? Okay? So I've got 2 times the cube root of x squared y to the 5th times, then I'm taking the square root of 16x to the 3rd. What's the square root of 16? Nope. It is 4. 4 times 4. Okay? So, I guess I could have written this over here. So, we've got 2 times the cube root. I'm going to write it bigger too because I didn't write it very big. Of x squared y to the 5th times 4 times the square root of x to the 3rd. Now, if we want to put this together, we need to change all the radicals to rational exponents. Because I've got an x here and an x here. I can put those together, but I can't put them together when they're under different roots. If they were both under square roots, I could just put them together. But they're under different roots. So I'm going to have 2x to the 2/3 y to the 5/3 times 4x to the, what's that one? going to be 3 on top. What goes on bottom is 2, because that is a square root right there. Okay. Adam, you can flip over to this page at least. That'd be a good idea. Okay. Questions so far? All right. Now here comes what causes panic, but we can do it. We're not going to panic. We're going to stay calm. We're going to put these together. I need to put the x's together. The y is easy because it doesn't have anything to combine with. The coefficients, what do I do with the coefficients? Just multiply those. 2 times 4 is 8. Okay? And then right here, what do I do with my exponents for my x's? I've got to get common denominators because I need to add them together, right? Because if I had x squared times x to the third, that would be x to the fifth. I just add those together, right? I'm doing the same thing here, but I'm having to do 2/3 plus 3/2. Okay, so I'm adding those exponents. All right, let's see. Connor, what would I use for common denominators to add 2/3 and 3/2? We won't flip because we're not multiplying, or we're not dividing. If we were dividing, we would need to flip. But to add, we've got to get those common denominators. So we would want to do like you told me on that other problem where we had 15 that we used. So what number for 3 and 2, what number could I use for a common denominator? 6. So I would need 6 and 6 on the bottom of the fractions. So I have to multiply this by 2 on top and bottom, so I'd get 4. And I have to multiply this one by 3 on top and bottom, so I'd get 9. And that would give me, that would give me 13 over 6. So I would have x to the 13 over 6 and y to the 5 over 3. All right. Most of the time, it's okay with me if you just leave these as rational exponents. Now, whenever you take a test on this, I think these will probably be multiple choice. So it's possible they put them back as roots, but and definitely on the exam, who knows what they'll do there. But we're just going to leave these as rational exponents because I don't really want to do anymore. Okay, questions? It's the same thing that we've been doing, but you are going to have some fractions that you've got to add or subtract or multiply some. All right, so let's look. We're going to do I'm going to pick just a few of these practice problems for us to do together. Okay, let's look at number 2. All right, number 2. The first thing we're going to do is look at that root and see if we can take the root. Cube root of 27. Hey, Zeus, what's the cube root of 27? Okay, 3. I've heard 3 and I've heard 9. So we're thinking what times itself 3 times would give us 27. So 3 times 3 is 9. 9 times 3 is 27. So it is 3. So the cube root of 27 is 3. All right. Then let's go ahead and we're going to do x to the 6 over 3, y to the 9 over 3. Now in this particular case, 6 divided by 3 is 2, so I just get 3x squared, and 9 divided by 3 is 3, so I get 3x squared y to the third. Okay. Let's try number 3. I've got a square root of 4x to the third times 2x to the fifth. Adam, what is the square root of 4? 2. And then how do I write x to what power? 3 over 2, right? Because this is a square root. It doesn't have a 2 out there, but we know there is one. So we've got 2x to the 3/2 times 2x to the 5th. All right, so what will I do with those coefficients, Adam? The big 2's. We'll multiply those. We'll get 4. Then I've got, what do I do with these exponents? What if I had a simple one? Like if I had x squared times x to the 3rd, what would that be? X to what power? 5th. I would add the exponents together, right? So I'm adding the exponents here. It's just not nearly as easy because I've got 3 halves plus 5, which I could write as 5 over 1, right? What's your common denominator for that? What number would you get on the bottom of the fraction so they match? Yeah. 2. Right, so the first one's fine. This one, we'd have to multiply by 2, right? So we'd have 3 over 2 plus 10 over 2. What will we get when we do that, Adam? Adding 13 over 2. So we would have 4x to the 13 over 2. Uh-huh. What thing? Like the 2x to the 3 halves? Or what do you mean solve it? No, I don't think we'll get the right answer to do that. Like raising it to the 2nd power, is that what you're thinking? Uh-huh. On number 3? No, you don't do anything. You can't change it at all because the only thing you're doing to it is taking that root. You're not squaring it or anything. Like you're not raising this to the 3rd power. Only the x is to the 3rd power. How are you getting 8x to the 8th? Oh, I see. You're trying to put. You cannot put those together because they're not both under roots. If this was under a root, you could do that. Okay, but it is not. Sorry, it took me a minute to get what you were asking there. So if you had two things that were both under the same type of root, so both of them are under square roots, then you could go ahead and multiply those together and then change it. But if they are, this one's under a root and this one's not, you can't put them together. You got to simplify this one first. Or if you've got one, let me skip down here, or maybe if we've got one like number 9, they are both under roots, but they're under different roots. So you can't put those together because they're different type of roots. If they were both 4th roots, then you could put them together, but you got a 5th root and a 4th root, so you can't put them together. So yes, that was a good question. It took me a while to realize what you were asking there. Thank you. Does everybody see what Malia was asking there? She was wanting to multiply this stuff together first, then take the root, but because this 2x to the 5th is not under the root, we cannot do that. If it was, then we could do that, and it would probably be easier. Yes. Okay. All right, let's do. I'm just excited to be here. 18 looks like a good one to do. Let's do 18. You mean 11? Okay, let's do 11. 11 looks like a great one to do. We're going to do 11, we're going to do 17. Alright. Alright. Okay. Alright, so 4th root of 81. It's 3, right? Because 3 times 3 would 3 times 3 times 3 times 3. That'd be 9 times 9, which is 81. So we get 3x2. Julie, what power would that x be to for this first one? 3 over 4. Good. And then that's times 2x to the 1/2. All right, so Tristan, what do we do with those coefficients? Not the coefficients. Coefficients are the big numbers. The 3 and the 2. What do we do with those? We multiply those. Then what do we do with the exponents? We add those. So we will do 3/4 times plus 1/2. Those do not have common denominators. So Tristan, what would we do to get common denominators? You can do it that way, or you could just multiply this one right here by 2. You could do it that way. All right. And what do you get when you add those together, Tristan? Very good. And so we would have x to the 5/4. Okay, questions on 11? All right, 17. This is going to be the last one we're going to do together today. So, you got a few options. You could simplify on the inside first because you've got x's and you've got y's on the inside. Or you could raise everything to the power first. I would probably avoid the fraction as long as possible. So I would probably do what's on the inside first. That way I could avoid the fraction as long as possible. So the first thing I would probably do is switch the negative exponents. So that would be x squared, x to the 4th, they stay. You'll have y to the 9th on top, y to the 3rd on bottom. Okay. Then if I'm still working on that inside, Cole, what can I do with those exponents when I'm dividing? Subtract. Good. So for the x's, I'm going to subtract. What do I get? Very good. And then for the y's? Very good. Now, you could have raised everything to the 1/3 power first, but then if you do, you might have to subtract with some fractions. So that's why I decided to wait on that. Now, what do we do whenever we were raising a power to a power? Like an easier problem would be like x squared to the 3rd. What do? We multiply the exponents. Do we have to have common denominators to multiply? We do not. So we're doing 6 times 1/3. 6 times 1/3. That's like 6/1 times 1/3. That gives us 6/3. What is 6/3? It is 2. So in the top, we get y squared. And in the bottom, we're doing 2 times 1/3. That's like 2/1 times 1/3. So that gives us 2/3. So we get x to the 2/3. No. I like these a lot better than the other problems. The power to powers where you're multiplying are actually a little bit easier because you don't have to have those common denominators. Okay? All right. This is not your homework. I wanted to do some of this